right, welcome back to Math Concepts 1. Today we are talking about multiplication and division of integers. So we'll talk about models for multiplications of integers, properties, integer division, order of operations on integers, and inequalities with integers. So one thing that might help us recall when we come to the integers is a chip model to help us understand negatives and positives. So we could use a chip model where there are 6 red chips and see that there are 3 groups of 2 red chips. And each chip is a -1. So if we wanted to find -3 times -2 and see that that's equal to +6, then we can start with a value of 0 that includes at least 6 chips and then remove 6 red chips. So to illustrate this, we can take our model and we start with a value of 0, like I said. So there are 6 positives and 6 negatives, but this value is 0. And we want to remove 6 red chips from this. So if we remove 3 groups of 2 red chips, then we can see that taking away 3 groups of -2 will leave us with +6. So if we start with 0 and we take away, if we have -3 groups of -2, then we're left with a +6. We can also use a number line model to think about integer multiplication. So the rules for this is that we start at 0 and we face the positive direction or the right. And if the number is positive, we walk forward, so we walk to the right on our number line. And if the number is negative, we walk backwards. All right, so for example, if we wanted to illustrate 2 times -3, 2 groups of -3, then we would take our number line and we would walk backwards 3, that's 1 group of -3, and we would walk backwards another 3 to get to -6. Now, if instead we had had -2 times -3, then we would use our associative properties to think about this as instead -2 times -3. So remember, negative tells us the opposite. So if we do 2 times -3 and we want to think about it as -2 times -3, then we think about this as the opposite of -2, or of 2 times -3. So we take -6, the opposite of 2 times -3, and that gives us -2 times -3. We can also think about integer multiplication using a pattern model. So if we think about 3 times -2 as repeated addition, then that means I'm going to add -2 to itself 3 times. So I have 3 groups of -2 is -2 plus -2 plus -2, and that leaves me with -6. And if I can use the commutative property, then I know that -2 times 3 is going to give me the same result. So -2 times +3 is the same thing as +3 times -2, so it's -6. To find -3 times -2, I can follow the pattern. I can see that 3 groups of -2 is -6, 2 groups of -2 is -4, 1 group of -2 is -2, 0 groups of -2 is 0. And so I can see that each time my answer is increasing by 2. It's 1, 2 bigger, because if I were to go the other direction, I'm having one more negative 2. So if I go the other direction, I'm having one less positive 2. So if I wanted to think about what negative 1 times negative 2 is, then I would go up 2 more. And then I would go up 2 more to get 4 for negative 2 times negative 2, and then up 2 more to see that negative 3 times negative 2 is 6. All right, so we can define integer multiplication by splitting it into cases. So in the case that A is positive or equal to 0, and B is positive or equal to 0, then A and B are whole numbers, and the product is just AB as we defined it for whole numbers. If A is less than or equal to 0 and B is less than or equal to 0, then when we multiply AB, we're going to just have the absolute value of A times the absolute value of B. And remember, absolute value tells us the distance from 0. So the absolute value of like negative 5 is just 5 because the distance from 0 is 5. 5 to the left. And then the last piece of our definition is that if one of A or B is less than 0 and the other is greater than 0, then A times B is the negative of the product of the two absolute values.